This video is going to cover section 5.3, and now we're going to talk about properties of logarithms. So it says, for this example, use the properties of logs to expand the following log expression as much as possible. Where possible, evaluate the log expression. All right, so remember, properties are essentially the same. Logs have essentially the same properties as exponents since they're inverses. So whenever you have, for example, let me grab a little notes page to kind of help explain what I was going to say. So if we have something like, I don't know, x squared times x cubed. So based off of exponential properties, we are going to add our exponents, x to the power 2 plus 3, to give us x to the 5th power. Likewise, if we had something like x to the 5th divided by x squared, we are going to subtract our exponents, x to the 5 minus 2, which would give us x cubed. So whenever we're multiplying two exponential expressions, we add them. Whenever we're dividing two exponential expressions, we subtract. Okay, so keep that in mind. Log base 14 of 5x. So it's the same thing as saying log base 14 of 5 times x. So we want to expand it so that way each term, the 5 and the x, each thing has its own log base 14. They're being multiplied. So just like we talked about multiplication, I can expand it using addition. So log base 14 of 5 plus log base 14 of x. So I can expand so that way they each have their own log base 14. It's multiplying, so I can expand it using addition. It says evaluate where possible. So if I can make the bases the same, then I could evaluate. But I can't make 14 and 5 the same. I obviously can't make 14 and x the same. So this is our final answer. Log base 14 of 5 plus log base 14 of x. All right, let's do another one. Use the property of logarithms to expand the following log expression as much as possible. Evaluate where possible. So ln of e u. So this is the same thing as saying ln of e times u. So I can expand this and say the natural log of e plus the natural log of u. The natural log of e plus the natural log of u. If you want to put it in parentheses, go for it. It doesn't really matter. Now we know the natural log of e is log base e of e, which we know log base e of e is just 1. So we can simplify this down into 1 plus the natural log of u. Log base e of u, I can't do anything there, so just leave it. 1 plus the natural log of u. Same thing for the next one. Use properties of logs to expand the following log expression as much as possible. Where possible, evaluate the expression. So log base 14 of t divided by 12. So just like we talked about over here, division, we can expand using subtraction. So I could have log base 14 of t minus log base 14 of 12. Because they're being divided, I can expand it so that they both have their own log base 14 using subtraction. Now, in order to simplify, I need to make the bases the same. I can't make 14 and t the same. I can't make 12 and 14 the same. So that's going to be our final answer. Log base 14 of t, notice this is a little subscript, minus log base 14 of 12. Last one for this page. Use properties of logs to expand the following log expression as much as possible. Where possible, evaluate natural log of v divided by e to the negative 6th. Now it's dividing, so I know I can split these up to have their own natural log using subtraction. So natural log of v minus natural log of e to the negative 6. Now I can't simplify natural log of v, but I can simplify natural log of e to the negative 6. We know natural log of e to the negative 6 is the same thing as saying log base e of e to the negative 6. We know that logs bring this exponent down out front. So it's the same thing as saying negative 6 times log base e of e. Now we know log base e of e is just 1, so basically that cancels out. So we're left over with let's come up here, I guess. Right? Natural log of v minus this whole thing simplified down to -6. Natural log of v minus this thing simplified down to -6. Those two negatives can make a positive. So natural log of v plus 6 is my final answer. That's as far as I can simplify it down. Natural log of v plus 6. All right, next page. Use properties to expand as much as possible, where possible evaluate. Log base 2 of e, it's the log base 2 of u to the 11th. So we know that this 11th power is going to come down out front. So 11 times log base 2 of u. I can't make the bases the same, so it's going to say 11 times log base 2 of u. If you write it as 11 log base 2 of u, that's fine. I don't have to put that little dot, but it just kind of looks weird with like 11 with the log. I don't know, so I kind of wanted that little dot to kind of help break it up. This is just u, so nothing else I could do with it, so just leave it just like that. All right, so now here's some we kind of talked about it, now putting it all together. Use properties of logs to expand the following log expression as much as possible, where possible evaluate. Log base 2/3 of x to the 17th. This is going to be times the cubed root of y to the 14th. So I can rewrite this as log base 2/3 of x to the 17th. Because it's being multiplied, I can rewrite it as addition. That way they both have their own log base 2/3. So log base 2/3 of the cubed root of y to the 14th. I want to rewrite the cubed root of y to the 14th using exponential form. So log base 2/3 of x to the 17th plus log base 2/3 of y, that 14th up top, it's going to stay up top, divided by our root 3, so 14/3. So now remember, logs bring these exponents down out front. So we have 17 log base 2, log base 2/3 of x, plus 14/3 log base 2/3 of y. These are not like terms. I can't make 2/3 and x the same. I can't make 2/3 and y the same base. So final answer, 17 times log base 2/3 of x plus 14/3 log base 2/3 of y. Let's do another one. Use properties to expand the following as much as possible, or possibly evaluate. Natural log of y to the 11th times y squared all over x to the 20th. So now I have three things. Y to the 11th times w squared divided by x to the 20th. So I want each variable to have its own natural log. So natural log of y to the 11th. This is being multiplied, so I'm going to add natural log of w squared. This is being divided, so I'm going to subtract natural log of x to the 20th. Again, these two are being multiplied, so I can write them both using a natural log with adding. This x to the 20th is being subtraction, so I can write it separate using subtraction. Now we know logs bring our exponents down out front, so all of these exponents are coming down out front. So we're left over with 11 times the natural log of y plus 2 times the natural log of w minus 20 times the natural log of x. Shoot. That's supposed to be an x. I really want my whiteout to work. No. Sorry, this must be x. Let me write it. 11 times natural log of y plus 2 times natural log of w minus 20 natural log of x. Not like terms. I can't, these are all base e, so I can't make the bases the same. Final answer. Final answer. All right, so now notice the next one says use properties of logs to condense the following log expression. The solution should be a single log with a coefficient of 1, where possible, evaluate. So now we're doing the opposite. Before we expand it, now we're going to condense it. So now they each have their own log base 3. We're going to write it together using 1 log base 3. Notice it's log base 3 of 216 minus log base 3 of 8. They're being subtracted, so I know I can condense it into the same log base 3 by division. So 216 divided by 8. So log base 3 of 216 divided by 8. 216 divided by 8 will give us 27. So just simplifying. So that's log base 3 of 27. Now I want to try to get my bases the same. I know that 3 times 3 times 3, 3 cubed will give me 27. So I can rewrite this as log base 3 of 3 cubed. All right, so now we know these logs bring our exponent down out front. So we have 3 times log base 3 of 3. We know log base 3 of 3 is 1, so that cancels out. So we're just left over with 3 times 1, which is 3. So that whole thing is just 3. And that's it for page 22. We go on to the next page. All right, so 2 more like this. Use the properties of logs to condense the following log expression. The solution should be a single log with coefficient of 1, where possible evaluate the log expression. That coefficient of 1 means that if there's a number out front, it's going to go back up as an exponent. We'll talk about that in the next problem, actually. Log base 8 of 32 plus log base 8 of 16. Now they're both log base 8, so they're both like terms. So I can condense it into the same log base 8. They are being added, so that means I can do 32 times 16, condense it using multiplication. 32 times 16 will give us 512. So it's the same thing as saying log base 8 of 512. Let's see if I could write it using the same base. We know 8 squared is 64. 8 cubed is 512. Let's put there. Log base 8 of 512, which we know is 8 cubed. Logs will bring this exponent down out front. So 3 times log base 8 of 8. We know log base 8 of 8 is just 1. I'm going to come up here. 3 times log base 8 of 8. We know log base 8 of 8 is just 1. So it's really 3 times 1, which is 3. Last one like this. Use properties of logs to condense the following log expression. The solution should be a single log with coefficient of 1. Where possible, evaluate. So 4 times log base 3 of 4 plus log base 3 of b minus log base 3 of 2. So notice this 4 is in parentheses here. So this 4 could be distributed to both terms, not the 2, because notice my parentheses are here and here. So it's only to those 2, so be careful. So I have 4 times log base 3 of 4 plus 4 times log base 3 of b minus log base 3 of 2. All right, working backwards. Remember that coefficient is 1. So before what we did was the exponents came down out front. Now we're working backwards. So now instead of being out front, we're going to put them back up as exponents. So now working backwards, these are going to go back up as exponents. So I have log base 3 of 4 to the 4th plus log base 3 of b to the 4th minus log base 3 of 2. Now 4 to the 4th, let's go and write that. 4 to the 4th power will give us 256. So log base 3 of 256 plus log base 3 of b to the 4th minus log base 3 of 2. So now they're all log base 3, so let's combine it into the same log base 3. 256 plus, so that means 256, and then we're adding so we can multiply that b to the 4th. It's subtracting, so that means we're going to divide 2. So 256, log base 3, they're all log base 3, so same log base 3. 256 plus b to the fourth. I can combine those together by multiplication. We're subtracting log base 3 of 2. That means I can divide that by 2. Always we want to simplify. So I can do 256 divided by 2. And that will give me log base 3 of 128 b to the fourth. All right, let's see. I want to see if I can simplify. Let's see if we get the same base, but I don't think so. So we know 3 cubed is 27, 3 to the fourth is 81, 3 to the fifth is 243, which is bigger, so I can't do anything else. I can't make them the same base, so final answer, log base 3 of 128 times b to the fourth power. Last thing for this section. Use the logarithm change of base formula to convert each of the following logarithms to the specified base, then use a calculator to approximate the log, round to 4 decimal places. So notice our calculator only has log, which is log base 10 common log, and natural log, which is log base e ln. Now I know some newer calculators have other ones, but just keeping it fair for everyone, doesn't matter what calculator we have, we both have those two. So what the change of base formula says, let's do this first example and then kind of go to the formula from there. Convert log base 16 of 2 from base 16 to base 10. All right, so I want to do base 10, which is common log. So just log, common log. So notice this 2 is kind of like up top and the 16 is kind of on the bottom. So I can rewrite this saying common log of 2 divided by common log of 16. This is our change of base formula. So putting this as a formula. One second, I want to make sure the best way. Try it. All right, so let me get this color. So change of base. Formula means I can do log base b of a. B and a are just some arbitrary number. Arbitrary means just like in general, could be any number. Equals log x of a all over log x of b. So notice that a is up top, it's going to stay up top. The b is on the bottom, it's going to stay at the bottom. X can be any base. It could be base 10 like it is here. It could be base e. It could be base 2 like we're going to do the next one. But that is our change of base formula. So let's do, now that we kind of know that, let's do the next two. So log base 9 of 3, changing it from base 9 to base 2. So they're both going to be log base 2. Log base 2. That 3 is up top, it's going to go to the top of my fraction. The 9's on the bottom, it's going to go to the bottom. So log base 2 of 3 all over log base 2 of 9. That's it. So just kind of like seeing where stuff goes. See that 3 is going to go up top, the b is going to go on the bottom. It told me to use base 2, so in this case my x's are 2's. Convert log base 20 of 12 from base 20 to base e. I need to put them in my calculator. I'll do that next. All right, so to base e. So we know base e is going to be ln, which is natural log. So ln on the top, ln on the bottom. That 12 is kind of up higher, so it's going to be the natural log of 12. The 20 is our base, so it's going to go to the bottom. So natural log of 12 divided by the natural log of 20. These mean the same thing. Log base 20 of 12 is the same thing as log of 12 divided by log of natural log of 12 divided by natural log of 20. Just two different ways of writing it. All right, so I'm going to show you something. Let's go through log in our calculator. So this is common log. So common log, using my button, common log button right here, common log of 2, closing my parentheses, that's all we're taking the common log of, divided by the common log of 16 equals 0.25. Let's go to this natural log down here. So using our natural log button right here, so natural log of 12, closing my parentheses, all we're taking the natural log of up top, divided by the natural log of 20, which will give us, it says round to 4 decimal places, so 0.829, and that 48 is going to round up to a 5, so 0.8295. All right, couple things. So we have natural log of, log base 2 of 3 divided by log base 2 of 9. So let me show you how to do that base thing that I was talking about, how you can put in base 2, because on here I only have common log and natural log. If you go to your math button right here, and scroll all the way down, right here it'll say log base, so press enter. And look, it kind of does it for me. So I can do log base 2 of 3, that's all I'm doing, so I'm going to scroll over, divided by, go in my math button, scroll all the way down to log base, press enter, log base 2, scroll over, of 9. So log base 2 of 3 divided by log base 2 of 9, and that will give us 0.5. All right, so I know some older calculators don't have this option. So you can also do common log of 3 divided by common log of 9. It's going to give you the same answer. You could also do natural log of 3 divided by natural log of 9. Same answer, doesn't matter. You could also do math, scrolling down to log base, and plug in the original problem. Log base 9 of 3 equals 0.5. It doesn't matter what the base is, you're changing it. So these are all equal the same, just in different forms. So if you have older calculator and you can't do base 2, you can use common log or natural log, change a base to get you your decimal approximation if needed. But that's kind of how you can plug it into your calculator. Most of the time, notice it wants the exact answer. It does not want a decimal, so we have to simplify logs by hand. But if you need to plug it in, that's how you can do that. You can also do that in your y equals. Use the math button, scroll all the way down to log base. You can do log base 2 of x, and it will graph that for you. So kind of cool. All right, that's everything for 5.3. Thank you for watching. If you have any questions, please let me know.